Here we have another rational equation to solve. We've got 20 over x squared minus 25 equals 3 over x minus 5 minus 2 over x plus 5. The first thing we've got to do is get all denominators factored completely. This first denominator is a difference of squares, so it can certainly be factored. And I'm breaking open two sets of parentheses to factor it. To get x squared minus 25, x times x would make x squared, and then 5 times 5 is 25. With differences of squares, one of the signs is always a plus and the other a minus. Positive 5 times negative 5 gives us negative 25. So the first denominator is factored completely. The second denominator here, x minus 5, cannot be factored, so I'm just copying the 3 over x minus 5, and then minus. The last denominator, x plus 5, can't be factored either, so I'm just going to copy 2 over x plus 5 to the next step. So all denominators are now factored completely. The next thing we've got to do is identify any restricted values. Those are values of x that make any of the denominators 0. So I'm going to make a note up here as to what x is not allowed to equal. X is not allowed to equal negative 5, because negative 5 plus 5 makes this factor 0, which zeroes out the entire denominator. X can't equal negative 5. Same thing from this last denominator. X can't equal negative 5 here either, because negative 5 plus 5 is 0. And then from this factor, x can't equal positive 5, because 5 subtract 5 would be 0. And same thing here, x can't equal positive 5 there either, because 5 minus 5 is 0 in the denominator. So x can't equal positive 5 or negative 5. Those are our two restricted values. If when we finish solving the equation we get either one of those values, we will conclude that that value is not a solution to the equation. So next thing to do is to multiply both sides of this equation by the least common denominator. So the LCD of this particular equation, looking at all three denominators, is we need an x plus 5 in it, and we also need an x minus 5. Those are the denominator factors that occur. So I'm going to show here multiplying on the left side by x plus 5 times x minus 5, and also multiplying on the right side by x plus 5 times x minus 5. We're trying to clear the fractions, and that's accomplished by multiplying every term in the equation by the LCD. So on the left side, the x plus 5 factors cancel each other, and so do the x minus 5 factors. So the left side just becomes 20. On the right side, we've got to distribute our x plus 5, x minus 5 to both terms and simplify. So we've got, let's see, 3 over x minus 5, multiplying that by x plus 5, x minus 5, and then minus 2 over x plus 5 times x plus 5, x minus 5. I used the distributive property there on the right side. So the left side is 20. We're done simplifying the left. On the right side, 3 over x minus 5 times x plus 5, x minus 5. The x minus 5s cancel each other. So we've got 3 times x plus 5, which is going to be 3x plus 15 if you would prefer to write that at this stage. And then minus, for 2 over x plus 5 times x plus 5, x minus 5, the x plus 5 factors cancel each other. So that makes 2 times x minus 5. So we've got a minus and then a 2 times x minus 5. Notice that the fractions have been cleared. The fractions are gone from the equation, and that's good. That was what we're trying to accomplish in solving a rational equation, getting rid of the fractions. So let's take a look at what we need to do to solve this. The 3 needs to be distributed through the parentheses, and the negative 2 needs to be distributed through the parentheses, to clear parentheses. 20 then equals 3x plus 15, and then a negative 2x. Negative 2 times negative 5 would make positive 10. Okay. This is just a linear equation, so all we need to do is combine like terms, get the x terms on one side and the constant terms on the other side. 20 therefore equals, let's see, 3x subtract 2x would be x, and then 15 plus 10 makes 25. So we've got x plus 25 on the right side. The last step here is just to subtract 25 from both sides, and we'll have x isolated on the right. So 20 minus 25 is negative 5. Negative 5 equals x. That's our one potential solution. We need to make sure that this solution actually is permitted by comparing it to our restricted values that we wrote down initially. So let's look back up here. X was not allowed to equal -5. Look at that. And that's what we got. So our answer actually is not a valid solution. Okay. This is not a solution. X is not allowed to equal -5. This was our only potential solution, and it doesn't check. So the conclusion to this equation is that there is no solution. Sometimes when you solve a rational equation, you get no solution that actually checks, and in that case, you just say no solution for the answer.